The semi-major axis of the Earth's orbit, is a very common unit in astronomy, and it's called an astronomical unit. It's a unit of length, astronomical unit, or AU. The mass of the Sun, mass of the Earth plus the Sun is mostly the mass of the Sun. Sun is called a solar mass, obviously, and it's given this symbol, M with a little circle with a dot inside. That's the symbol for the Sun. And what's the orbital period of the Earth? A year, thank you very much. Period of Earth. 1 year. That's what a year means. It takes a year for the Earth to go around the Sun. So it must be the case that one astronomical unit cubed is equal to g times the mass of the Sun times 1 year squared, that's p squared, over 4 pi squared. Now, let me show you a trick. Take the general equation, this is a useful trick, and divide by the specific equation. So, a cubed equals p squared gm over 4 pi squared, and we're going to divide that by 1au cubed equals 1 year squared g, mass of the Sun, over 4 pi squared. We can do this because these two things are equal, so we're dividing both sides of the equation by the same amount. G cancels, 4 pi squared cancels, that's very nice. We end up with a over 1au cubed equals p over 1 year squared, m over the solar mass. This is just saying that quantity is a in units of an astronomical unit. This quantity is p in units of a year. If this is 2 years, then this number will come out to 2. And this is m in units of the mass of the Sun. So you can say a cubed equals p squared m, providing you're dealing in units of the mass of the Sun, units of 1 year, and units of an AU. So this is now much easier to work with. You've got rid of all kinds of terrible things. So let me give you the first numerical example of the course. This will be the last thing we do today, namely the orbit of Jupiter. Turns out the distance from Jupiter to the Sun is about 5 times the distance of the Earth to the Sun. So A of Jupiter is approximately 5 times A of Earth. A of Earth, you'll recall, is this 1 AU, so this is about 5 AU. So how does this equation work out? You get 5 cubed equals p squared m. M is the mass of the Sun, 1 solar mass. And since Jupiter is going around the Sun, that's equal to 1. So you have 5 cubed. 5 times 5 is 25. 25 times 5 is 125. So you end up with 125 equals p squared. So you can answer the question now, what is the orbital period of Jupiter in years? Obviously, that's going to equal the square root of 125. Here's another trick. What's the square root of 125? Quickly. Good. More decimals? You could type it into your calculator, though, and find out. But let me make a suggestion. Don't take the square root of 125. Take the square root of 121 instead. What's the square root of 121? 11. Much easier, right? And notice this. A of Jupiter is approximately 5. So 5 cubed is approximately 125. And it's just as good to say 121 is equal to the square root, the square of the period, and p equals 11 years. That's the orbital period of Jupiter. All right, so now I'm aware that many of you are shopping the course today and may not be back for future lectures. And so I want, for those people who have decided against this, that they'll do something far more worthwhile with their time, I want to leave you with something you can carry through your life from your brief experience with Astronomy 160. And that is the following piece of advice. Don't take the square root of 125. take the square root of 121. It's much easier. This is what the business people call thinking outside the box. Don't do the stupid hard thing. Do the thing that is just as good, but requires some thought first in order to make it easy. And so I will leave you with that. The rest of you, I'll see you on Thursday morning.